Hi, Year 5. Good morning, and how are you today? I hope you had a good night's rest. We're reviewing lesson 13 today. Yesterday, we completed the review of lesson 12. So let's see lesson 13 review today. Remember, we did position and movement. That's our topic, and we had 3 units in this topic. The first one is how to read and plot coordinates. How do we read coordinates? If you remember clearly on this lesson, I said to you that we read coordinates by connecting the number on the horizontal axis with the number on the vertical axis on each point of a shape. Now look at the example we have here. We have a triangle. How many points does the triangle have? 3 points. The first, the second, and the third point. Now, to be able to read this coordinate on this triangle, we're going to pick the numbers where the first point of the triangle connects. The numbers are 1 and 3. Please note, it is from the horizontal axis that we read the number first. Then we pick the second number from the vertical axis. For each point, there are 2 numbers. One comes from the horizontal axis, and the second one connects on the vertical axis. Remember when we did plotting of graphs, you have to connect your horizontal axis with the vertical axis, and then you put the dots and connect the dots. Here also it's something similar, so it's good that we've done plotting of graphs earlier. So let's look at the first point of this triangle. Remember that we will pick from our horizontal axis first. The number on the horizontal axis for the first point is 1, and on the on the vertical axis for still the first point of this triangle is 3. So the first point has coordinates 1, 3. Let's see the second point of the triangle. Pick the number first from the horizontal axis. On what number does it fall on the horizontal axis? 5. Point 2 of this triangle is on 5. Then, on what point is it on our vertical axis? 3. So we can say that the second point is on coordinates 5, 3. What about the top, the last point of the triangle? Let's look at our horizontal axis. It's on 3. And from the vertical axis, the dot is on 7. So we can say we have coordinates 3, 7. So this triangle can be labeled by the coordinates 1, 3, 5, 3, and 3, 7. Okay? All right. Remember, just like I said, the coordinate on the horizontal axis is what you write first before the one on the vertical axis. Now let's see how to plot coordinates. We've seen how to read it from the previous slide. So let's see how we can plot coordinates. This exercise we took from the workbook, page 212. We already have the coordinates, okay? So here we're supposed to make the dots and connect them. The first one, now let's see what shape this is going to give us. The first one is coordinates 3, 2. Now, where are we going to pick the 3 from? Horizontal axis. Remember, the first number will come from the horizontal axis. So look down at the horizontal axis where we have 3 and connect it with 2. 3, 2. Connect it with the 2 on the vertical axis. So where are we going to have our points? Coordinates 3, 2 will be here. Now let's see the next one, 8, 2. Coordinates 8, 2. 8 from the horizontal axis, 2 from the vertical axis. Let's connect it. It will be here. The next one is coordinates 8, 6. 8, 6. 8 from the horizontal axis and 6 from the vertical axis. Let's connect it. Where will it be? over here, 8, 6. All right, and finally we have 3, 6. 3 from horizontal axis. Let's connect it to 6 on our vertical axis. Look at what we have. Now let's try to close or connect our dots with lines. Okay, we connected this, and then this, and then this, and the last one. Now, what shape do we have? We have a rectangle. It's a rectangle because if you count the boxes, the box on the horizontal side is 4. No, it's 5. And the boxes on the vertical side, they're 4 of them. So 5 and 4, it means it's a rectangle. A rectangle has all same sides. So this coordinate has produced for us a rectangle. Now let's see unit 2. The second topic we did in this lesson is reflection. Now what's a reflection? We can say that a reflection has happened when a shape or an object is still on the same distance and it's still the same shape from the line of reflection. The shape does not change, the size does not change. Okay, when it is reflecting on the line of reflection the same way, then we can say a reflection has happened. Now let's see these two pictures we have. Can you see that what we have in the actual picture is reflected in like a river that is underneath? That's our mirror. Okay, that's what is going to be reflected or described as our mirror. Now let us see where the line of reflection can possibly be here. See, our line of reflection is right here, and if you look at the actual shape, it has the moon, it's got the stars up there, it's got the tree, and there's like a bar of sand underneath the tree. The same thing is reflected in the river. The same size, the same shape, and the same picture. So we can say a reflection has happened. What about the second stones? We have stones here, and as you can see, we have white and white, brown, and well, we have different colors of shapes of stones. And if you see the reflection made in the river, it is still the same number of stones that we can see. Do you notice that? The shapes of the stones did not also change. So we can say that we have a line of reflection here. Do you see? After the line of reflection, the shape still remains the same height and the same size. Okay? So here we can say a reflection has happened. Now let's see these shapes that we have here. It's an example from our student's book. We're going to see shapes that reflect well in the line of reflection and the ones that do not. The first group of shapes we have up there, they are shapes that are reflecting well on the line of reflection. The red line in the middle is the line of reflection. The actual shape probably is the deep blue one, and the reflection is the one that is white. Now, can you see that the first group of shapes we have up here, they are the same size, they have the same distance from the line of reflection. Each of the shapes have the same distance from the line of reflection. So we can say that a reflection has occurred. Now let's look at shapes that are not reflecting in the line of reflection. Look at the second group of shapes we have underneath. For example, look at the square. The square has shifted position after the line of reflection. It is still the same size, but it has changed form. It has moved away from where it ought to be. Look at the one we have here, pentagon. The pentagon has increased in size, so in fact, we cannot even say that it's reflected well. Now look at the trapezium we have. The trapezium should or would have reflected well, but what is the problem with the trapezium? The actual shape, that's the one with the deep blue, Can you see the distance of the actual shape from the line of reflection? Now look at the reflection and look at the distance between the shape and the line of reflection. The distance is shorter, so we cannot say it has reflected well. Also, the rectangle, the distance between the actual shape, the one in deep blue, and the other one, the reflection, is different. So the distance has to be the same, size has to be the same also. The last rectangle also has already changed shape. It has changed its form. It's still a rectangle, but it has moved from being horizontal to being vertical. So we can't say they reflected well on the line of reflection. Now let's try this one. So we're going to describe if these shapes are reflected in the line of reflection. Now take a quick look at the shapes and study them carefully. All right, let's see shape A. Shape A, all right, now let's have it done this way. Now look at shape A. Here is the actual shape. All the ones in deep blue are the actual shapes. This is our line of reflection. And this is the reflection. Now, do you see that the shape is not changed in form, not changed in size, and it has the same distance from the line of reflection? So can we say that it is reflecting? Yes, same distance from line of reflection, same shape and size. So the line, we can say the shape reflects. What about shape B? It's the same size, it's still the same shape. But what's the problem with shape B? This is our actual shape, our line of reflection, and that's the reflection. Look at where we have the problem. It's the same shape and size, but it's not the same distance from the line of reflection, so it does not reflect. What about C? It's the same distance, it's the same shape and size, so we can say the shape reflects. Let's see D. D is also the same distance from the line of reflection if you look at it. But what's the problem with shape D? The reflection has changed in size. It's supposed to be a square, but the reflection has become a rectangle, so it does not reflect. And finally, shape E, it's the same distance and it's the same size and shape, so we can say the shape reflects. And finally, we go to unit 3, the translation. When do we say there is a translation or a translation has happened? It is when an image or a shape moves from one place to another, but along a straight line. Mind you, I didn't say along the same line, I said along a straight line. Now let's have this example. Here we are going to be using grids again. We have this grid and I have this triangle. Of course, now you know how to plot coordinates, you know how to connect your lines, and you connect your dots, and you know all about reflection and plotting and reading coordinates. Now look at this shape. It has 3 points, like you know. It's going to move now. Let's see where it will move to. It's moving over here, the new triangle. Now, what we must do is to define or give an instruction on how the shape has translated. How has the shape translated? So let's give an instruction. By how many boxes on the grid? We have boxes on the grid, right? So let's start from the first point. Count from the first point of the triangle, the first point where we have coordinates 1, 3. Now, the new triangle is now on coordinates 5, 3. So what does this mean? Let's count by how many boxes the first point has moved. From here to here. How many boxes in between? 1, 2, 3, and 4. So let's see the second point. The second point of the triangle moved from this point to this point. We also have 4 boxes in between. Let's see the one at the top. It moved from here to here. If you count, you see that we have 4 boxes in between each of them. Now, I'll tell you a little secret about translation. The moment you are able to get the first one right, the first point of your shape, the moment you're able to get the movement of the first point correctly, you will not make a mistake on the others, because if you know by how many points or how many boxes the first point moved, then it will be the same on all the other points of the shape. So now let's give an instruction for this shape. We can say the triangle in the grid has moved by 4 places to the right, because you can see it's the interval between each point is 4 boxes. So it has moved 4 places and it moved to the right hand side. Now let's see this example we took from our workbook. This now has given an instruction: translate the square to 3 squares to the right. The instruction has been given. We are the ones now to plot the translation. Now let's try to plot. Remember, we take it point by point. Where is the first point of this shape? This is a square. Don't mind the way it looks. It's because of the way the picture was taken. This is a square. Okay, now from the first point, we are supposed to count 3 squares to the right. Here is our first point. Now let's count 3 squares to the right and see where the new point will be. We have 1, 2, and 3. This is where the third point stops, or the third square rather stops. Let's see point 2. Point 2 is here. Let's count now 3 squares to the right. 1, 2, and 3. This is where the new point 2 will be. Now remember that I said something to you. If you are able to get your first point correctly, you are very unlikely to make a mistake in the other parts. So it's important to get your first point very correct. Now let's plot the one up. This is point 3. Count 3 squares to the right. 1, 2, and 3. This is point 4. Let's count 3 squares to our right. 1, 2, 3, and it stops here. So we just connect the dots. And this is our new translated square. Now let's see the next one. We're supposed to translate this rectangle's 5 squares down. Now I've seen some of your work and you still need to work on it. You still need to do some corrections. So pay attention to this carefully. Where is the first point of this rectangle? Here. So what are we going to do? We're counting down. So we're going to count from this point 5 squares down. So we have 1, 2, 3, 4, and 5. This is where the fifth count stops. Now count it again. 1, 2, 3, 4, 5. This is where the fifth one stops. On point 2, the same thing applies. Remember I said if you get the first point correct, you will not have a problem with the other points. So 5 squares down is here. Point 3, count 5 squares from point 3. We have 1, 2, 3, 4, 5 is going to end here. The same thing applies for our last point. Count 5 squares down here, and then we connect the dots. So we have our new translated rectangle. We have translated the rectangle to 5 squares down. So thank you so much, students, for your time. Till we have another lesson in our next class, take care of yourselves and have a great day.